Good afternoon, everyone. I hope your day is going well so far. Please put your pencil down, pick up your colored pen, and let's share out our results and see how well we did warming up for today. So you were asked to simplify each expression. We're going to go one at a time. Number one, let's share out. I've got student 16, 13, 9, and 24. Student 16.
60 radical 2.
Okay, student 13.
60 radical 2.
What was yours, Maddie?
60 radical 2.
60. Okay. Student 9.
I couldn't figure everyone out.
Student 24.
Oh, I only got as far as 3 radical 4 times radical 5.
Okay. So, what I was hoping for was 60 radical 2. Number 2, I've got sharing out student 5, 6, 22, and 18. Student 5 does not seem to be available. Student 6, what'd you get?
30 minus 5 radical 3 over 36.
Student 22.
I did it.
And student 18.
5 radical 3 over 9.
So, what it comes out to is 30 minus 5 radical 3 over 33. So, I'm going to hit my magic rewind button. Rewind, rewind. Let's go back to number 1. What can be interesting about this is that there's actually quite a number of different paths, and it's really up to you to decide how do you want to solve the puzzle. Not solve an equation, just the puzzle of how should I simplify this. So first, let's survey. Give me a thumbs up if you got 60 radical 2. I already know of 2 people who did. Good. Put your thumbs down. Let's start with Evdell, and then we're going to come over to Christina, and then we'll work our way around. Evdell, what was the first thing you did? Okay. How'd you do that? Okay, so you bring up something important, which is that the calculators I provide will just tell you the answer. So if I wanted you to get practice with typing, then I would have said, use your calculator, type this in so you practice how to type. That's not really what I was intending. You didn't know, and that's fine. My intention was for you to use only your brain to figure this out. And yes, I do have calculator checked off, but you can deduce that I want you to work this through yourself, okay? So Christina, what was the first thing you did?
Well, I saw that it was a radical 40 and radical 20, so I thought, well, it cancels out the radical 20 and it makes another one. So it's 3 radical.
What do you mean it cancels out the radical 20? What does?
The radical 40.
Okay, well the radical 40 doesn't cancel out the radical 20. I know what you're trying to say, but not everyone can follow your logic until we break it down for them. So what did you do with the radical 40? You did something to it.
Yeah, I did something. I don't know what I did.
Okay, well I'll tell you what you did. You changed it to radical 20 times radical 2. Now we didn't touch the 3, and we didn't touch the first radical 20. So in essence, we've got 3 times radical 20 times radical 20 times radical 2. Now I'm going to help you focus in your eyes so you can see what she saw. What happens when we do this times this? Something magical happens that we explored yesterday. They sort of, not cancel each other out, they
Get rid of the radical.
radical, and we're left with the number 20. So now this becomes just 20. We haven't touched the 3, and radical 2. 3 times 20 is 60. 60 radical 2. But that is in absolutely no way the only way to do it. So how else could you have done it? Go ahead, Samar.
I multiplied the radical 40 times the radical 20.
Good, so we have an alternate path. So let me do an alternate path over here. And what do you get when you multiply them together?
3 radical 800.
3 radical 800. And actually, this is how I did it myself. And so you did the smushing. You smushed them back together. You used the product property to smush them. And then, Samar, I don't know if you did it the same way as I did. What did you do next?
I broke down the 800, so then it was 3 times 20 radical 2.
Okay, but you broke down the 800 into what?
20 times radical 2.
20 times 2 is not 800.
400 times
You're skipping a step.
Yeah.
What she did was she broke this down into square root of 400 times the square root of 2. You can tell me I'm right, because I know. Now the square root of 400, 400 is a perfect square. So now we've got 3 times 20 times 2. Wow, what an elegant method. But yet, we get the same result we got over here. Any other ways of doing it? Go ahead, Jaylene.
Well, I got the radical 800, but I broke it up into radical 8 times radical 100.
Okay, and I actually, that's how I started, and I almost did it, but I was like, wait, 8 has a factor of 4, so then I realized I could go the other way, but that was how I was going to start. So let me branch off, let's branch off from here and go over here. And so you broke it into 3 times radical 8 times radical 100, because you saw the 100. And the square root of 100 is 10. So now we've got 3 times the square root of 8 times 10, and we could put the 10 with the 3, and we get 30 radical 8. And you were able to keep on going from there? And so then she sees that radical 8 is actually radical 4 times radical 2, and we can continue that way. But again, you get the same result. Wow, 3 different paths. Amazing. Any other approaches? Okay, so let's jump over to number 2. I heard some chatter that some students were confused about what to do. Oh, that's reasonable. So give me a thumbs up if you got number 2 correct. Okay. Good. So let's start with Noah, and then we're going to come to Abigail, and then David. Noah, what did you do?
I saw that there was a radical on the bottom, so I multiplied it by like the opposite. So 6 minus the radical of 3.
Okay, so I was very deliberate, and I actually said that we really can't call it an opposite, but I understand the spirit of what he's trying to say. So what was the word that you were introduced to that described it? It's a conjugate. But he's right. Look, he understands what he's doing. So we multiply times the conjugate, but you have to do it the top and the bottom. And then what we figured out was that this is really a sum and difference pattern. And when you FOIL it, however you like to do it, you get the square of the first number, the square of the second number, and then the middle terms cancel each other out. And in this case, you end up with a number. But you also have to distribute the top. 5 times 6 is 30. 5 times negative radical 3 is 5 radical 3. And now let's FOIL. 6 times 6 is 36. And then we do radical 3 times negative radical 3 is going to be negative 3. The middle terms cancel each other out. 36 minus 3 is 33. So I'll back up. I'm not suggesting in any way that this is easy, but if you think about it, it's really a combination of 2 things. Remembering something, it's a combination of 3 things. It's recognition, remembering something, and then knowing your algebra gymnastics. Recognition, remembering something new, conjugate, and then algebra gymnastics, which you should be an expert at this point, but maybe you need a little work, but that's okay. Are there any comments or questions or thoughts, observations? Any new theories you'd like to test out? Okay, well, good job getting warmed up. So today is part 2 of our lesson about simplifying radicals, but now we're going to use radicals to solve some quadratic equations. So let's jump right in. There are no new notes. There's nothing new. It's just context. That's the only thing new is context, which means situations. So we're diving right into example 1. Don't worry about part B yet. In fact, let's wipe that out. We'll get to that in a minute. Now, I'm going to do something. I don't want you to write this at all. I just want you to consider it. If we wanted to, based on what we've learned so far, when solving quadratic equations, we actually want to get the whole quadratic on one side and a 0 on the other. So, if we follow that, we would want to subtract 41, we get 3x minus 36 equals 0. Did I do that right? No? Sorry, squared. And now I could say, okay, well, 3 and 36 have a common factor of 3. So we could divide everything by 3. We get x squared minus 12 equals 0. And then, I don't know, I'd have to try and figure out how to factor that. Or maybe use the quadratic formula or something. But there's an elegant alternate approach. Because we have this powerful tool of taking square roots, which undoes a square, then we can take an alternate approach. So let's use our magic rewind button. Instead, if we recognize that there's no linear term, a linear term is an x term. So if this was 3x squared plus 2x plus 5, that's the linear term. That's the x term. If there is none, you can likely use square roots. So in this case, we solve it more like when you solved linear equations way back at the beginning of Algebra 1. Which means we actually get everything on one side of the, we get the x squared on one side and everything else on the other. So now we go in the opposite direction. Now you can join me in doing some work. If we subtract 5 from both sides, now we're left with 3x squared equals 36. Simple algebra gymnastics. How do we get rid of the 3? Divide everything by 3, and I mean everything. So that will disappear, and we're left with x squared equals 12. Yes?
Before when you were doing the, before this problem, before you tried this way, couldn't you have just added 12 on
Yeah,
the side?
absolutely. Right.
Just that x alone.
All I'm doing is now recognizing that that was what should have happened right from the beginning. But yeah, absolutely. And I'm really glad you recognized that. So now, how do we undo the squared? We take the square root of that, but we have to do it to both sides, so we take the square root of that. But here's where you need to be careful.
You have 10th graders in here?
No.
No, you only have 9th graders?
This is the one class I only have 9th graders.
Perfect. I don't think we need those.
Okay, thank you. So, here's where you need to be careful, because what we just did was we are taking the square root of x squared, which is x, but now we get two solutions. It's plus or minus square root of 12. But now we know that we don't write square root of 12. We can write it in simplest form, which goes way, way, way back to maybe 4th or 5th grade, when you learned if you get the answer of 4/6, you don't write 4/6. What do you write? 2/3, because that's simplest form. That's acceptable. This would not be acceptable. Definitely not in my class. So now we need plus or minus the square root of 12 in simplest form. So what is it in simplest form?
Plus or minus 1.
What can we split 12 into?
Plus or minus 2 radical.
So we split it into the square root of 4 times the square root of 3, And then the square root of 4 equals 2. Now, Samar, you did something, and I know you know what you did, but it's actually a really common error. Because we're so good with our minds, we're so quick, that we go, oh, it's just 4 radical 3. Not realizing that, okay, really what you did was you split it into square root of 4 times the square root of 3. And so the real result is plus or minus 2 radical 3. So Samar, I want you to understand that I hear this and see it every year. So just be mindful of it. Anyone have any questions on how we can creatively solve quadratics if there's no linear term? Go ahead.
Okay, so on the part where it was 3x to the second equals 36, couldn't you just square it then?
Square root it?
Yes, square root it.
Well,
so then it
be
will
careful. Squaring and square rooting are two different things.
And then it would be easier because 36 is a perfect square.
Yeah, but now we have a problem on the left-hand side.
Oh, but then after that you can divide it by 3.
You would have. Hold on.
Radical 3 though.
It would end up being the square root of 3x equals plus or minus 6. Then you'd have to divide by the square root of 3. And now you've got a little bit of a mess. Now here's the thing. Algebra gymnastics is algebra gymnastics. Why do I use this phrase all the time? Because it's a routine, right? In gymnastics, and I'm not a gymnastics expert, but hopefully you've seen some gymnastics at some point in your life. If you see a floor exercise, one participant might do a cartwheel, a backflip, and then another cartwheel. But a different participant might do cartwheel, cartwheel, backflip. Do they both get results? Absolutely. So you can do this, and you can keep on going. This would actually work, but you would have to make sure you do it. You can't have the radical 3, so then you'd have to do square root of 3 over 3, and you'd have to keep on going. Okay? Good, I'm glad you brought it up. Now I gotta rewind, so hopefully it'll rewind for me. Any other questions or comments? Any observations before we go a little bit next level? Jabari, go ahead.
If you square root into 3x squared, wouldn't it just be 3x without the radical?
No, because you do the square root of 3 as well.
No, square root of 3x squared.
And then that would be 3x without the radical.
Square root of 3 times the square root of x squared. 3 is not a perfect square. You can't take the square root of it. Okay. So you're bringing up something similar to what Samar brought up a few minutes ago, which is students sometimes start doing unusual things with radicals, disregarding them, or thinking that you don't have, that it's not really there, or doing it when you're not supposed to do it, or not doing it when you are supposed to do it. So just be mindful that it is a bit of a danger zone. So let's go up to part B. So now we're going to go a little bit next level, although it's really not that big a deal. In part A, x squared was nice and friendly. All we had to do was isolate the x squared. In part B, we have the square of a binomial. And if we wanted to, we could multiply the whole thing out. You multiply the square of the binomial, so that's a shortcut. You could do square the first term, square the last term, and do the middle term. So we could do that. I don't want you to write anything, but it would be 1/5 times z squared, and then this would be a 9, and then this would be 6z equals 7, and then we could multiply both sides by 5, and then we'd have a big giant mess on our hands. And then you'd have to subtract the 35 from both sides, and you'd have to clean it up, and you'd have a lot of work to do. So we can use the idea of square roots creatively again, because we have this entire expression is being squared, so if we use a square root on that, it will undo it. But we have to isolate it first. So how do we isolate the part that I highlighted? What do we have to do first? Any thoughts, or what do you gotta do? I hear some people muttering some things. Get yourself involved.
Multiply both sides by 5.
Get yourself involved. I have same 4 people who speak. Go ahead. Multiply both sides by 5. That will get rid of the 1/5, and then you're left with z plus 3 squared equals 35. Now we can use the square root tool to get rid of that squared. So we can square root this entire thing, but then we have to do the other side, and we get the plus or minus automatically on the right side. And so this square root this time gets rid of that, but we're left with the z plus 3. So we've got z plus 3 equals plus or minus the square root of 35. We're trying to find what value of z will make this true, so we need to get rid of that plus 3. So what can we do? Subtract 3 from both sides. So we get z equals negative 3 plus or minus radical 35. Now let's see, can we clean up square root of 35? Do you have any perfect square factors?
No.
It's divisible by 1, 5, 7, 35, and that's it.
Yeah.
So it's actually in simplest form already. So those are the solutions. And what that means is if we plug those expressions back in here, we would make that a true statement. This also means that if we plug this into Desmos, it would cross at negative 3 plus radical 35 and negative 3 minus radical 35. Let's estimate that. Let's see, what perfect square is 35 really close to? So the square root of 35 should be more than 6 or less than 6? Little, like a hair less than, right? So let's see, if negative 3 plus approximately 6, we'd be about 3. And if we did negative 3 minus about 6, it'd be negative 9. So if we graph this, it should cross at negative 9 and 3. We didn't even need a calculator. Anyone have any questions or thoughts? Any shortcuts or observations? All right, checkpoint number 1. Let's see what you could do on your own. You got 4 minutes. All right, let's see how we did. Remember that this is part of the learning process. Doesn't really matter if you get them all right, all wrong, or one right and one wrong. What matters is what you do with it. So let's share out. Part A and Part A only. What did you get? I got student 15, 14, 17, and 1. Student 15, what'd you get?
X equals 2 plus or minus radical 13.
Okay, student 14.
X equals 2 plus or minus radical 120. I didn't finish.
Okay, student 17.
X equals 2 plus or minus the radical of 13 and 1/3.
Square root of 13 and 1/3. Okay, and student 1.
X equals 2 plus or minus radical of 13.3.
Okay. So let's see. Hold on. So you said square root of 13 and 1/3? Oh, I see what you did. You guys pulled out a perfect square that was multiplied by... Okay. All right, let me think about it. Jaylene, what was it again?
X equals 2 plus or minus the square root of 13 and 1/3.
Square root of 13 and 1/3. So we just need to find out, is this equivalent to that?
You put 1/2.
Oh, it's 1/3, sorry. Thank you. So we just need to see if those are equivalent. So let's see. I'll approximate. So we got 13.3, and we'll take the square root of that. It's about 3.65. And the square root of 30 times 2 divided by 3. Yeah, it comes out the same. Same thing. Yeah, I had a feeling you guys were right. It's okay. So either way, I'm happy. Let's jump over to part B. I've got sharing out student 18, 16, and 6. Student 18.
Oh, number 2, I got z equals 11.
Okay, student 16. Hold on. One more time.
Z equals plus or minus 6.
Okay, and student 6. So, plus or minus 6. Unfortunately, if you just put 6, it is incorrect. And plus or minus is not some magical new symbol. It just means positive 6 and negative 6, if I could write. It's just a short way of writing both. But if you don't write both, if you just wrote plus 6, then you're indicating the wrong thing. Think of it this way. If we saw a graph of this, then it should cross at negative 6 and positive 6. And let's see, it's going to open up, so it should go something like this. If you only tell me 6, you're telling me that the graph goes something like that. That's totally different. So you need to be clear about what you're doing, okay? So are there any comments, questions, concerns, observations, anything about part A or B? So we'll start with Abigail, Jabari, and then Leah.
I don't understand how you got 2 radical 30 over 3.
Okay, what did you get?
Well, I only reached up to x equals 2 plus or minus radical 120.
Okay, so it comes out to 2 plus or minus square root of 120. Okay, so what's 120 divisible by? 4 times 30. Okay, so I need to go all the way back. Let's see. If we divide both sides by 3, what happened with that? So this is, you multiply both sides by 3. Okay. All right. So let's continue building. So now let's solve some real problems with all of these ideas that we now have bouncing around. guys ever done the egg drop experiment?
I've heard of it before.
If you've never had an opportunity to do it, you should figure out a way for you to be able to participate in it. It's a classic experiment and experience that everyone should have. They even do it at the Museum of Discovery and Science every year. You get to drop your egg from the second floor down to the first floor. It's a lot of fun. I don't remember when they do it, but you should try and find a way to try it. It's really interesting. So students have to design some sort of container that prevents the egg from breaking when it's dropped from a height of 50 feet. How long does the container take to hit the ground? Now, we're taking out of the scenario friction, air resistance, and all of those things. We're keeping it simple. This is not a study in science. This is a study in mathematics. So, if you didn't know, this is using a particular function that exists in the world that's used all the time. It's called the vertical motion model. You should have been exposed to it in Algebra 1, but if you weren't, it's okay. So the vertical motion model is h equals negative 16 t squared plus vt plus s. This is called the vertical motion model.
I remember something.
And so, there's a lot of variables going on, so you need to know what they mean. S is the start height. Start. T is time. H is the ending height. And V is the vertical velocity. Velocity. The reason that there's negative 16 is because this has to do with gravity. The force of gravity is 32 feet per second, something like that. So that's half the speed of gravity pulling down, half the force of gravity pulling down. So now we need to fill in what we know. Okay? So let's fill in what we know. We know the start height. What's the start height? 50. So that's going to be right here. The negative 16 is going to stay there. We are asking for how long. How long. So we're looking for time. So that means that the t needs to stay there. So t squared is going to be here. Plus, and then there'll be a t here. But we need to fill in the velocity. And we need to fill in the ending height. So, anyone know either of these? We actually know both of them, but let's see what we figured out. We need the velocity and the ending height. Go ahead, Javante.
Would the ending height be 0?
What led you to that conclusion? That's exactly right.
Well, because if you're gonna drop if you're gonna drop it from like a certain amount of height, then obviously from the beginning height it would have to be 0 because all you're doing is going up.
Okay.
If that makes sense.
Okay, sort of makes sense. There's also a key word in here that tells you that it needs to be 0.
It's the ground.
The ground. So you're right. So what you were basically trying to say is the ground is our starting point, and then we're dropping it from somewhere above the ground, so that has to be 0. That's what I got from what you said. So that's why it's 0. But what about the velocity? So let's now envision the scenario. All right, let's pretend that I'm the participant, I'm the student, and I've got my egg in a special container I created. So is this what's going to happen?
No.
0.
So what did you just do? So literally, this is what you do, and this is what they do at the Museum of Discovery and Science. They hold it over the railing. They go 3, 2, 1. So what is the vertical velocity? 0. It's nothing because we're not applying any force to it. There's no external force. We're not using our muscles. We're not using a pumpkin launching machine that shoots it out. So now, what happens to that middle term?
It
this is going to disappear because 0 times t is 0. So in actuality, what we are left with is this function. 0 equals negative 16t squared plus 50. So solve the equation. You can solve it any way you want, but we now have practiced some skills that should allow you to figure it out. What would the first algebra gymnastics move be? Go ahead, Garrett.
Minus 50.
Yeah, if we subtract 50 from both sides, this will disappear, and we've got negative 50 equals negative 16t squared. And what would our next algebra gymnastics move be? Divide both sides by negative 16. Now, here's where math classroom versus real world is important. So in the previous example, the results came out like this with radical symbols and plus or minus. But what are we actually looking for in this question? We're looking for an amount of time. So does it make sense, like, if I were to talk to my son and he asked me, Dad, what time are we having dinner? In about radical 10 minutes. I mean, that doesn't make any sense. He'd be like, he's 8 years old. He'd be like, what are you talking about? So in this instance, a real number would make sense, right? Not a real number, but like an approximate number that we can visualize and kind of understand. So now, in this case, maybe actually doing, well, we already know that's going to be positive. 50, oh, you're already ahead of me? Okay. Divide by 16, and now what do we have to do with that? Well, let's see. We've got 3.125 equals t squared. So now, square root on your calculator. And so it should take about 1.77 seconds. Now technically, we get t equals plus or minus 1.77 seconds. Because we're not going back in time. So it's 1.77 seconds. Anyone have any questions about how we started with very little? I mean, really, there was one number in the entire question, and yet we were able to build something and solve something from very little information. Any questions or comments? We'll start with Diego, and then we'll go around.
So whenever it's a real world question, we have to actually find the numeric value, not just.
It depends. You're going to have to think about it.
No, but like in the homework, if you have like a.
You're going to have to think about it. It should be clear. Okay? If I don't write the question clearly enough, if it's ambiguous, like it seems reasonable, you can answer it either way, then I should have the answers programmed that would accept it either way. But if I ask for an amount of time, it's going to be an amount of time. Okay? Any questions? All right. So that brings us to you trying to figure something out. So, checkpoint number 2. You got 5 minutes because you need a minute to read and then 4 minutes to work it out. Remember, my job is to push you. This is independent. Whether it's right or wrong doesn't matter. We don't know the thumbs up system after. Give me a thumbs up if you have a result. Okay, good. So I'm going to cut the time. So let's share out what your results are. So please, we're coming back as a whole group. Oh, we got volunteers? Okay, good. So we'll start over here with Javante, and then Edel, Abigail, and then David. Go ahead, what'd you get?
40 months.
Okay, what do you think?
I got 40.
You got 40 as well, Abigail?
40.
I got 3 people who think 40.
C equals 40.
Okay, so I was looking for the 40th month or 40 months. Very good. Good. Well, so let me survey. I have to do a thumbs up again. Give me a thumbs up if you got the right answer. Okay. Good. Put your thumbs down. So I have a couple of people that I'm going to come visit. So, but it seems like we had some good success with this. Did you use square roots to solve it?
Yeah.
No.
Yes.
A lot of people said yes, some people said no. Okay. So let's see what we can do as a team. So, I'm going to give you 5 minutes to work as a team.
Well, let's see. 1 plus R over
Work as a team. Try to contain your discussions within your team. 5 minutes isn't quite enough time to figure this out, but let's see how far we can go.
annual interest rate.
And it's
R
times
there's a no
so
and
the
is
number of
R
times.
times interest rate. P is the original $7.21.
R divided by how much?
So you figured out what it was, so you have to answer the question.
12 times itself, 12 times. What? So we do,
No, not the entire thing.
no, it's 8.91610048.
Okay, let's go back together as a whole group. So, my little hint is that mathematically it's actually really easy. The hard part is figuring out how the function works. This is a real function that's used by banking industry all over the world. This is how you calculate compound interest, which is what makes people money by letting their money sit in a bank. The more something is compounded, the more money you make. The more frequently it's compounded, the more money you make. So if something's compounded weekly, you're going to make more money than if it was compounded monthly or each year. So I intended much more time than 5 minutes. That's my fault, not yours. So what we are going to do is we're going to basically treat this like hitting a pause button, and we're going to revisit this question. I'm not sure if it will be revisited on Tuesday, but sometime in the next 2 to 3 days, we will revisit this question. So we're going to hit the pause button. I am very proud of your effort. And let's wrap up. Your homework, your follow-up is now due Tuesday. So it says tomorrow, Tuesday. And your Chapter 1 test is a week from today.